This question is from 2019, the 36th question from 2019. And this question is about collisions of particles. So we have to use the concept of conservation of linear momentum as well as the concept of energy. Let's go through the question very quickly. Consider 4 metal balls of same volume placed on a smooth horizontal surface. Mass of each of the first 3 balls is m, while the mass of the fourth ball is 2m. They are equally separated on a straight line. The first ball moves with speed v and collides with the second ball, resulting in a series of linear elastic collisions among the balls. So what is the meaning of linear elastic collisions? Kinetic energy will be conserved. Kinetic energy will be conserved. That's important. That is the meaning of elastic collisions. Linear elastic. So no energy loss. Therefore, before the collision, whatever the energy was there in the system should be available after the collision as well. After all the collisions, the motion of each ball is best represented by. Now, if you look at the answers, if you take the first answer, they are saying only m will be moving towards left and the other 3 will be at rest. According to the second answer, they are saying the first 3 will be at rest, the last one will be moving at v by 2. And the third answer, first mass is moving towards left at v by 2, the final mass is moving towards right at 3v by 4. Likewise, they have given answers. So if they have not indicated a velocity of the object is at rest after all the collisions. Right. Let's analyze this one by one. Right. Now I will explain this step by step. Fine. So let's draw a small diagrams here. M, and then 2m. This is how the masses are. All have same volume, so same size, but masses are a little different. Initially, this is moving at v. These are at rest. This is how the initial point is. So the first step. After the first collision, what will happen? This particle will come to rest because it's a elastic collision. So this particle will come to rest. Second particle will start moving at velocity v after the first collision. The third and fourth will be waiting for that ball to reach them. So they are still at rest. This has stopped. Why? Both the masses are identical. If the collision is elastic, what will happen? The velocity will be interchanged. And next collision will happen between these two. Then what will happen? The first object has stopped now after the first collision. Second object will also stop after the second collision. And the third object now will be moving at velocity v. And the fourth object will be waiting for that. Until this, no problem. Okay, right. So first 2 objects are at rest. Now third object is moving towards this at velocity v. Right. Now I'm going to analyze that little bigger. Okay, just before the collision, this is what's happening. M is moving towards 2m at speed v. 2m is at rest. Now here, you can't say that since the masses are different, this velocity cannot be interchanged, this object. If you consider by any chance, if you consider it like this, m comes to rest and 2m goes with v by 2. If you consider that way, what have I done here? Initial momentum is mv. Now final momentum is also mv. Now 2m into v by 2, momentum is equal. But this is incorrect. You know why? If you take like this, I'm saying this is incorrect. Let me explain that. What is the initial kinetic energy before the collision? If not, I'll say kinetic energy before collision. Kinetic energy before collision, that will be equal to how much? Half mv square. That is kinetic energy before collision. If you take this as after, this is a guess. We have taken this as a guess. And if you take that, this as the correct one, then second one is the answer. But I'm saying it's incorrect. Why? Kinetic energy after collision, if you consider, it will be little different. Kinetic energy after collision will be how much? Half into 2m into v by 2 square. If you take it this way, and that will be 2 and 2 gets cancelled off. We will be getting mv squared by 4. Here it is mv squared by 2. Hope you can understand. Here it is mv squared by 2 before collision. Only m is moving at velocity v. After collision, 2m is traveling at velocity v by 2. If we consider that, all of its momentum is transferred to this object. So that is incorrect because the collisions are, sorry, the kinetic energies are not equal before and after collision. So I can say, so collision is not elastic. If the collision is elastic, before the collision and after the collision, kinetic energies must be equal. Therefore, this is incorrect. So this assumption is incorrect. Therefore, the correct approach should be this. Now, just before the collision, excuse me, just before the collision, object of mass m was moving at velocity v, and object of 2m mass was at rest. And after the collision, you have to, now we don't know that we can't say anything about the velocities. There will be two unknowns. One is this, mass m will recoil at velocity v1, whereas the heavier mass will move to the right. This is what's going to happen. The heavier mass will move to the right. Okay, two things must be considered here. One is momentum and the other one is energy. Both must be considered because there are two unknowns. V1 also we don't know, V2 also we don't know. So first of all, you have to consider final linear momentum. Final linear momentum should be equal to initial linear momentum. Right. So what is the final linear momentum? Okay, this is the direction because initial linear momentum is in that direction. What is the final linear momentum in that direction? It's going to be 2mv2 minus mv1 equals initial linear momentum is mv. Right? Fine. Then you can get rid of v, v and v. Finally, you will end up in a relationship like this. That is 2v2 minus v1 equal to v. Equation 1. And the other thing, since this is elastic collision, you have to say final total kinetic energy must be equal to initial total kinetic energy. Initial total kinetic energy. Okay. Now, what is the final total kinetic energy? This is where you have to be really careful. It is half into m into v1 squared plus half into 2m into v2 squared. Now, I put plus here. I did not put minus here. Here, I used minus. The reason is, people, kinetic energy is not a vector. It is a scalar. Energy is a scalar. No? So, for energy, we don't consider direction. You have to add everything when it comes to energy regardless of the direction. That is why I have put plus here. Here I have put minus because it is momentum. It's a vector. And the initial total kinetic energy is how much? Half mv squared. All right. Okay. Then now let's cancel out the common stuff. This m can be cancelled out. Done. And I think you can cancel out this 2 and this 2. Right. And everything I will multiply by 2. Okay. Everything let's multiply by 2. And you will end up in something like this. See if you can agree. V1 squared by 2 is V1 squared when you multiply that by 2 plus I have only V2 squared. If I multiply that by 2, it will be 2V2 squared equal to, here it's going to be V squared. Here it's going to be V squared. Okay, fine. Great. Then we have to simplify this. What's the plan? How are you going to simplify this? Yeah, the only option is equating them. No, people. The only option is going to be equating them because we need V1. We need V1 or V2. One of the values must be found out. Correct? We have to find out one of the values. So what shall we do? We know an equation for, we found an equation before, right? Yeah, this one. Okay, this one. What if I substitute that here? Let's try substituting it here. V squared. So it's V1 squared plus 2V2 squared equal to V squared. What is V squared? 2V2 minus V1 squared. Right. Then this part will be V1 squared plus 2V2 squared. And here you will be getting 4V2 squared minus, you have to multiply these 2 and 2. That will be 4V1 V2 plus V1 squared. Hope you guys understood this. What have I done here? Hope you can remember from O level, A minus B squared is equal to A squared minus 2AB plus B squared. I have applied the same thing here. So instead of A, we have 2v2 minus v1 square. So what should I write? Instead of a, I should put 2v2 squared minus 2 into 2v1, 2v2, sorry, 2v2 into v1 minus v1 square. So that's what I have written here. Then you can see, I will continue it here. I will continue it here. Right. If you see carefully, you can cancel out v1 square and v1 square. Here, you can cancel out those. All right. Then we are almost there. Don't worry, we are almost there. Then the 4v1, v2 goes to the left side. And here I have 4v2 square. This 2v2 square comes to right side. Then I will end up in 2v2 square. All right, fine. Then if you simplify this further, you will be getting this 4 and this 2 can be cancelled out. Here there is a 2. This v2 and this v2 gets cancelled out. Right. Finally, we end up in something like this. 2v1 is equal to v2. 2v1 is equal to v2. Okay. Right. Then we can finish it off. What can I do here? Instead of v1, let's take v2 by 2 and substitute here. So I'll be getting the first equation. I'll be getting what? 2v2 instead of v1, v2 by 2 equals to v. Therefore, this will be 2v2 minus v, that is 3v2 by 2 equals to v, and I'm getting v2 is equal to 2v by 3. v2 is equal to 2v by 3. In how many answers do we have that? Only in one answer. Nah? Look at this one. This one. So the correct answer should be fourth one. Okay, but I'll explain how this v by 3 came. v2 is equal to 2v by 3. v2 is equal to 2v by 3. And what is v1, people? Now we know v1 is v2 by 2. So from that you can find out v1 is equal to v by 3. All right, v by 3. So after the collision, what happens is this. After the collision, you will have M, and 2M here, right? So after the third collision, after the third collision, 2M will be going to the right at 2v by 3, and M will be going to the left at v by 3. Again, M will collide with this, v by 3. Again, M will collide with this, another v by 3. So ultimately, you will get a situation like this. So this is how you have to approach this question. I know it's a bit challenging, but if you are good with O-level maths, I think this is pretty much manageable. So the answer is fourth. A projectile suddenly explodes into two fragments with equal masses at the highest point of its trajectory. Now that is something very important. Let me draw a structure like this. Highest point of the trajectory, people, at the highest point of the trajectory, remember the object will have only the horizontal component, correct? It will only have the horizontal component. I'll take it as v, the velocity. The vertical component will be 0 at the highest point of the trajectory, that is p, point p. This is the first thing which should come into your mind. And I'll take the mass of the object as m, okay, m. This is just before collision. Just before collision. So just before collision, we have mv to the right. That's all. There's no vertical velocity. All right, fine. Now I'll draw it here again. I'll draw it a little bigger because it is already separated to 2 now. So mass is m and it will have a velocity of v just before collision. Just before collision. Right. After the collision, one of the object, now what will be the mass of each object, people? What will be the mass of each object? It will be m by 2 and m by 2 because it is separating into 2 identical masses. Now let's go to the question. If one fragment falls vertically downwards, 2 fragments with equal mass, one fragment falls vertically downwards with an initial velocity as shown. So this object has an initial velocity. I'll take it as v1. It has an initial velocity. All right. Which of the following diagram best represent the path of the other fragment? That means they are talking about this object, the fragment on the top. Okay, now you have to analyze the velocity of that fragment. So I'll get rid of this P because I need that space. People, now look at the initial linear momentum of the system. What is the initial linear momentum of the system, people? Initial linear momentum is only mv towards right. That's all. Mv towards right. So final linear momentum should also be towards the right side. There can't be any resultant vertical momentum. Therefore, if m by 2 is going down at v1, this object should also be going up at v1. Hope you guys understood that. Why is that? Initially, right before the explosion, actually, right before the explosion, right before the explosion, um, right before the explosion, what was he saying? Yeah, there is no horizontal component. Sorry, there is no vertical component. That means after the collision also, the vertical component must be zero. There is one vertical momentum that is downwards because of one of the particles. So the other particle should have a momentum in the upward direction to balance it off, right? Therefore, yeah, fine. And then another problem is, this is just before collision. There is a momentum towards right. After collision, there is a momentum towards downwards that is balanced by the momentum of this object upwards. So there is nothing to balance this one as of yet. So to balance this momentum, there must be a velocity towards right as well, like this, v2. All right. Hope you guys understood that, because before the explosion, mv towards right is the linear momentum. After the explosion, one of the particle is going down. It can't happen that way because initially there is no vertical momentum. So the other particle will go up at the same velocity to balance the vertical momentum. Now vertical momentum, resultant momentum is zero after the collision. Initially there was a momentum towards right. So we need a momentum towards right after the explosion as well. So this is just after explosion. Just after explosion. Therefore, you can see the second fragment, one fragment is falling down. The second fragment will have a vertical component and a horizontal component. Therefore, subsequently, it is going to go like this and fall. It's going to eventually go like this. Now, which answers are definitely wrong? First is wrong, second is wrong, third is wrong. So we have to choose between fourth and fifth. Correct, people? We have to choose between fourth and fifth. First and second and third are wrong. Okay, what is V2 then? What is the value of V2? Let's start. Final linear momentum towards right should be equal to initial linear momentum towards right. Right. What is the final linear momentum towards right? M by 2 into V2. And initial linear momentum towards right is mv. Therefore, V2 will be equal to 2V. Because m and m will get cancelled off, V2 will be equal to 2V. That means the velocity of the second fragment is double the previous velocity. Okay. If the particle had gone at velocity v, it would have landed here. If there was no explosion, it would have landed somewhere here. Okay. What is this path? If there was no explosion. But after the explosion, one particle has gained double the velocity, because just before the collision it had velocity v. Now suddenly the velocity has doubled. Therefore, the distance traveled by the particle horizontally should also be what? Doubled. Hope you can agree with me on that. All right. After the collision, velocity has doubled. Therefore, horizontal distance covered by the particle should also be double. Then when you compare fourth and fifth, which one do you think you can agree to? Which one do you think is the correct answer? Which one do you think is the most accurate answer, guys? Right. The most accurate answer is the fourth one. Because in the fourth one, you can see the displacement has doubled. Right. So the answer for this question is fourth. It's a mixture of linear conservation of linear momentum and projectile motion.